Hi, and welcome to another video on object-oriented programming in C#. With me, Marinas Toman. Okay, in this video we're going to look at data collections and lists. So I'm just going to go through a Microsoft tutorial for creating lists and managing data collections just using the generic list type. So this tutorial teaches you C# interactively using your browser to write C# code and see the results of compiling and running your code. It contains a series of lessons that create, modify and explore collections and arrays. So if you haven't watched the video on arrays, it might be a good idea to do that first. Okay, so let's get into it. Okay, so running the following code in the interactive window, select Enter Focus Mode button, then type the following code block in the interactive window, okay, and then hit run. So let's copy this, paste it here, so click run and we can see that we're just going to output everything in the string list to upper. So let's talk through these lines here. What does this mean? So the var keyword is just basically when we declare a generic type. So this really has no type, it'll accept any type at all. So another way that we could do this is having list and then of type string called names, and then that's a new list of type string. Okay, so that's the same. You know, at runtime the var variable is going to become a list as soon as it runs, and this is assigned to names, this list, then this variable is just going to act like a string list anyway. So in our for each loop, again this is good for looping through arrays and lists. You just do, again, this can be any type. We have a local variable that we're declaring here called name, and then we just say in and then the name of our array or list. So for each name in the so for every time it loops through the index, it's going to basically save whatever string is here into the variable name, and then we can access it through this variable. So the first time this loops, you're going to see name, and it's going to put all of the characters to uppercase, so as you can see here. And then the second time it's going to Anna is going to be stored in name, and then name to upper is going to be hello Anna, and then the third time Philippe. Okay, so yeah, I've created a list of strings, added 3 names to that list, and printed out the names in all caps. So we're using concepts that we've learned earlier about loops, arrays, and the string class as well. The code to display names uses string interpolation. So this is when you precede a string with this dollar sign. You can embed C# code in the string declaration, and as you see here, it's always between curly brackets that we put our string interpolation. So the actual string replaces that C# code with the value it generates. In this example, it replaces name.toUpper with each name converted to capital letters because you called the string.toUpper method. Okay, so pretty straightforward. Lists are like arrays, they're just data structures. So it's a data structure that you can store multiple values of the same type. And the main difference between a list and an array is going to be a fixed size, but a list can keep growing or shrinking in size. So we'll keep going through this and keep going through this tutorial. So the collection you created uses a list T type. This type stores sequences of elements, and you specify the type of the elements between the angle brackets. So that T just represents a generic type. One important aspect of this list T type is that it can grow or shrink, enabling you to add or remove elements. So you can see the results by modifying the contents after you've displayed its contents. Add the following code below the code you've already written, so below the loop that prints the contents. Okay, so let's go below this loop. We're just going to write a blank line. Now to the list names, we're going to add some new data. Okay, we're going to add another name called Maria, another name called Bill, and then we're going to remove Anna. So you can see at this stage now, we're going to have 5 elements in our list, and then once we remove, it's going to go back down to 4. So we're going to see now when we try and print things out again, that there's only going to be 4 elements. Okay, you can see Anna has been removed. So you can see how the list grows and can grow and shrink just by adding and removing elements. So you've added 2 more names to the end of the list, but you've also removed 1 as well. The output from this block of code shows the initial contents and then prints a blank line and then the new contents. So this is our initial contents, blank line, and then our new contents. The list T enables you to reference individual items by index as well. So you can access the item using the square brackets. And the following code below, add the following code below to what you've already written to try it out. Okay, so let's try this to see. So we can access it the same way that we can access an array. So this should give us the name of the first element, so that's going to be this, and then these are the ones that we've added. So let's run this and see. Okay, my name is name, I've added Maria and Bill to the list. Okay, so you're not allowed to access past to the end of the list, and you can check how long it is with the count property. So when we looked at arrays, we've seen that we could get the length of the array with the length property. Well, this is the same in lists, only we call it the count property. So let's copy this. So the list now has how many people in it? Yeah, it's 4 now instead of 5, because although there was 3 and then we added 2, we removed 1. Okay, so in C#, indices start at 0, so the largest valid index is 1 less than the number of items in the list. So when this has 4 people in it, the last element in the list is number 3. So that's always, good to remember that. It's the same as arrays, the index starts at 0. Okay, so next we look at searching and sorting lists. So our samples use relatively small lists, but in your applications you may often create lists with many more elements, sometimes numbering in the thousands. And to find elements in these larger collections, you need to search the list for different items. The index of method searches for an item and returns the index of the item. If the item isn't in the list, index of returns -1. So we'll try it to see how it works. And we put this below what we've written so far. Okay, so it's getting the names list, and we're calling the method index of in the list class, and then we're just passing in a name, and we want to see where is this name? Is this in the list? And if it is, return the index that it's at. So if the index isn't -1, so if we do find it, then we can print, the name is at and then the index. So if we try then and put in index of not found, which isn't in our list, this will show us, what returns when an item isn't found in the list. So let's run this and see what our output is. So the name Philippe is at index 1. When an item is not found, index returns -1. Okay, so anytime you see, if you're searching for something and use index of and it returns -1, then you know it's not there, it's not in the list. Okay, you may not know if an item is in the list, so you should always check, check the index returned. If it is -1, then the item was not found. So that's what we're doing here. We're just checking, if it's not -1, then that means it was found, so you can go ahead and print what was found. The items in your list can be sorted as well. So the sort method sorts all the items in the list in their normal order. So that's alphabetically for strings, because remember, strings are just characters, and characters have an ASCII integer associated with them. So it basically goes from smallest to largest, or if it's strings, alphabetically. So if we do a sort on our string names, then what we should see is these are going to be sorted alphabetically. But it'll be interesting to see where this name string goes, because it doesn't start with a normal character. Okay, so let's run this. Okay, so you can see it did put name first. And then Bill, Philippe, Maria. So when you have the names listed out like this, Bill, B, F, M, that is alphabetical, but it's just because of this less than symbol here that name, it treated that as the first character, not the N. Okay, so the good thing is that we can search through our lists. We can to find the index of a certain element, or we can sort our lists, into alphabetical order for strings, or into ascending order for integers and doubles. Okay, so moving on. So lists of other types now. So far we've been using the string type in the lists. So let's make a list T using a different type. Okay, let's build a set of numbers. Delete the code you wrote so far and replace with the following code. Okay, so over here do Control A to select all and delete. So creating a new list, a new integer list called Fibonacci numbers. So it's just 2 values so far. So the Fibonacci sequence is a sequence of numbers that starts with 2 ones. So far this is a Fibonacci sequence. Each next Fibonacci number is found by taking the sum of the 2 previous numbers. So this code will do, we'll basically get the next number in the Fibonacci series. Okay, but because what's this doing? It's getting the last number. Count -1 will go to the very last index, because the count at this point is 2. So this is 0, 1. So we need 2 minus 1, and that will give us our index of 1. And then we want the one that is basically before this one, so before the last one that was entered. And we're going to just call these previous and previous to. Okay, so in the first time that this goes, it's just going to take this number into the variable previous, and then this number into the variable previous to. And then we're going to use the add method from the list class. So we're just going to add to the list the sum of both of these variables. And then we're just going to print out our whole list. Okay, so you can see it gives us the next value, which is 2, so that's good. Okay, so see if we can put together some of the concepts from this and earlier lessons, expand on what you've built so far with Fibonacci numbers. Try and write the code to generate the first 20 numbers in the sequence. And as a hint, the 20th number is 6765. Okay, so there are a couple of different ways that we could do this. So we know we're going to need a loop anyway. This is the code that gets the next, basically gets the next in the series. So what we want to do is just loop this like 20 times. So we could do a for loop, or we could do a while loop that will stop so while the Fibonacci numbers length is less than 20, that could be a valid loop to use. Then we just want to keep adding numbers into our list each time, so count all of our numbers. So this is going to keep the list is going to keep increasing. So as long as this number here is changing, this loop should end as soon as we hit 20, because we don't want to get to 20. We only want to generate you know, the 19th element, which is the 20 anyway. Okay, so let's see, does this work? Oh, something happened. Okay, yeah, that's 6765. Okay, that's pretty good. So you can see now, you know, some of the main differences between lists and arrays, and one of the powerful things is that lists can grow or shrink, whereas arrays have to be a fixed size, because you're basically allocating, you know, a piece of memory when you're using arrays. But with lists, what we're doing is we're encapsulating all of that functionality inside a class. So, you know, some other smart programmer has created this functionality inside a class that we can use, you know, like sorting or adding, removing, all that stuff. Okay, so yeah, that looks pretty similar to what we came up with. So with each iteration of the loop, you're taking the last two integers in the list, summing them, and adding that value to the list. So the loop repeats until you've added 20 items to the list. Okay, so the list count is, once it's equal to 20, then that's when it stops. Okay, so that's everything for lists and collections and lists. So I'll share this tutorial in the video description, and I would advise you to go through it yourself, you know, and practice using arrays and lists. Okay, so that's everything for the video. Thanks for watching.